Okay, picking up with yield to maturity. Yield to maturity is just solving for the interest rate. I mean, technically, it's the interest rate that makes the present value of the cash flows equal to the bond's price, right? Well, really what yield to maturity represents is, we've talked earlier in our previous examples, we've looked at, all right, if you know the rate of interest in the economy, what would the bond sell for? But usually what happens for investors is you go to a bond dealer and they quote you a price. So you know the price of the bond. And you also know the specifics of the bond. It's a 10% coupon, or in this case 11% coupon bond that matures in 3 years. And you say, well, if I pay for it at that price, is that a good deal for me? And the yield to maturity is a way to kind of say, okay, lets me know what kind of deal I'm getting. So the yield to maturity says if you pay this price for the bond and then you hold it until maturity, right, then you will earn that rate of return on your investment, 6.47%. So you would say, all right, if I pay this price, I'm going to earn 6.47%. Can I do better elsewhere? If the answer is no, then it's probably an investment you might take. But if the answer is yes, I can easily beat that return, well then no, I don't want to buy this bond, right? So we are just solving for I in our equation here. That's yield to maturity. Another way I think about yield to maturity is it's just the I key on the calculator when I'm dealing with bonds. Right? Now remember, when we solve for I, the present value needs to be negative. Okay? And notice what this represents. The negative is you're paying for the bond, and then you can see that the bond returns these payments to you, so they're positive. Okay? Now, I have this equation here just to make a point. This is very hard to solve by hand. In fact, the only way to solve these by hand is to guess what you think R is, and then plug that in, and then see if you get the right price. And as you might imagine, that's not real easy to do. We used to teach, I don't know, 30 years ago, we used to teach students how to do that, and honestly I'm not old enough to have done that, not yet old enough, but I have had colleagues that remember teaching students how to do this. Strategies for guessing R so that you could solve these problems rather quickly. I guess the reason I'm going through this is you should really appreciate your calculator or the spreadsheet software or whatever it is you're using to solve these problems. They make it enormously less complicated and faster and a lot easier to do. And it's amazing to me that people were able to do these kind of transactions and calculations in the 30s before we had mechanical equipment even that would do these kind of calculations. So the calculator makes these a lot easier. So if you put these numbers in the calculator, it will give you the yield to maturity of 6.47%. Remember, you'll get an error if you don't put a negative sign on this, on the price of the bond. Okay. All right, so here's one for you to practice. So stop the recording and see if you get the right answer here. I'll calculate it out for you now. So let's see, N is 9, the coupon rate is 8%, so 80 is the payment. Future value is 1,000. It's selling for 1,105, and I have to make that negative. That goes in for present value. And then I'm going to compute I. 6.43% if you round it, so B is the answer here. Okay. Yes, now most bonds have semi-annual coupon payments. Virtually all bonds that are sold in the United States work this way. They have semi-annual coupon payments. Now, to be honest, most of our example problems just assume annual payments just because they're easier. They still make the point. You don't have this extra complication, but we usually give you a few semi-annual problems just so you know they exist, you know how to deal with them. So the thing with semi-annual payments is the bond will still specify everything in years, but then you have to break it down on your own as semi-annual payments. So it'll say it's a 3-year bond, it matures in 3 years. You have to realize that means there are 6 semi-annual payments, right? So N will be 6. If it's a semi-annual bond, you'll double the number of years. It'll be 2 payments per year, right? Now, obviously, the present value stays the same because that only happens once. Okay? You pay some money for it today. It doesn't matter whether it's semi-annual or not. You just pay for it today. So present value stays the same. It's just the price. Now, the payment, the coupon rate is specified as an annual rate. That's what's printed on the bond. But if it pays you semi-annually, then what it does is it takes this coupon payment and divides it by 2. So in our case, it's 11% coupon. That means you get $110 per year, but you're going to get half of that every 6 months. So the payment then is, in this case, going to be 55, 110 divided by 2. And the future value is 1,000. You always get paid 1,000 at the end on the day the bond matures. Doesn't matter whether that's semi-annual or annual. It's just one day. It's going to pay you that at the end. Right, now if you put this in the calculator, you'll end up with 3.27%. And that would be answer choice C in a multiple choice exam. But that's wrong, right? You have to remember this semi-annual bond. N is the number of semi-annual periods, and the payment is the semi-annual payment. So the interest rate that it spits out to me, the calculator calculates for me, is going to be per semi-annual period. So every 6 months, that's half a year rate. So the yield to maturity is defined as an annual rate. So what we do is we just multiply that times 2. And so the official answer here would be the 3.27% you get from the calculator times 2, and the answer is 6.53%. Okay, and here's one for you to practice. Take a minute and put those calculations through. So 5 is in. The coupon's 130. Oh, see, I've already made a mistake. N is not 5, it's 10, because this is semi-annual payments. And the coupon rate, the payment's not 130, it's that divided by 2, which I guess is 65. 65 is the payment. The future value is still 1,000. The price is 900, so 900, that's got to be negative. And I'm going to compute that yield to maturity. I did something wrong. Let me do this again. N is 10. 65 goes in as the payment. 1,000 goes in as the future value. The present value is 900, and it's negative. And then I compute the yield to maturity. I get this. Notice this is answer A. That's not correct. That's the semi-annual yield. Right? What I want is a yield to maturity. I've got to take that number times 2. That's 15.98. C is the answer. Okay? All right. Okay, so I'll stop the recording. I'll pick up with bonds and interest rate risk on the next recording.